Hello everyone, welcome back to my channel. Here we start with the third video, third part of number system. If you can recall, so it's actually part 3. If you can recall, in my last video, we have ended with the fact that real numbers is equal to rational numbers union irrational numbers. We have already discussed the definitions of rational numbers and irrational numbers, and also we have concluded the fact that real number is equal to rational number plus or union irrational numbers. That is, the composition of these two equals to real number set. So we will I'll try to explain that how we can conclude to this conclusion. So real number is actually the union of rational numbers and irrational numbers. Like if we want to plot the number 3, 5, randomly I'm taking the numbers 7/2, √2, etc. on the number line, how will it look? If I'm drawing the number line, this is 0 mark, this is 1, 2, 3, 4. Again, this is -1, -2, -3, -4, -5. So 3 is actually this point. This is 3 point. This is, if we make another point, 5, this is 5. 7/2, as we know, it's equals to, or if I take -7/2, it will be -3.5 somewhere over here. That is -3.5. And √2 value, as we know, it's equal to 1.414. So 1.414 means it's, if I'm making the divisions between 1 and 2, it will be 1.1, 1.2, 1.3, 1.4. So somewhere after 1.4, so in between 1.4 and 1.5, we have to plot the point. That is 1.41. That is equals to √2 value. So we can understand over here that all the numbers, no matter it is a rational number or it is an irrational number, it could be plotted on the real number line. Henceforth, we can conclude that real numbers is actually the union of rational number as well as irrational numbers. There is another set of numbers which cannot be plotted in this coordinate plane. We know that real numbers, actually we know the coordinate plane, that is x-axis and y-axis. Real numbers are plotted in, this is 2D coordinate plane, are plotted in these coordinate planes. But as we know, this is one real line, this is another real line. But in higher classes, you will be learning another set of numbers, that is complex numbers. I hope I will share that chapter also one day. So let's come to now to the decimal representation of rational numbers and irrational numbers. So here we write this as decimals. Decimals are actually, they are of two types. The first one is terminating and the second one is non-terminating. Non-terminating are actually of two types. The first one is repeating and the second one is non-repeating. Now terminating, what are terminating decimals? Let's come to the definition first. Now here we come to the definitions of terminating and non-terminating decimals. Terminating decimals, let's come to this first. The terminating decimals are those set of numbers which will end after few repetitions after the decimal point. Like for example, if I take 1 by 4. So if I now dividing 1 by 4, it will be 0.2s are 8, then 20, it's 5. As you can see over here, after 2 places of decimal, the remainder is coming 0. That type of number which terminates after certain places of decimal are termed as terminating decimals. Coming to non-terminating, repeating. So repeating, non-terminating, repeating decimals are those types of decimal numbers which follows a particular pattern and which repeats after decimal point, which follows a particular pattern and which repeats after the decimal point. We will come to this, like if I'm taking an example, suppose I'm taking the example as 1 by 3. If you divide 1 by 3, 0.3s are 9, again 1 0, it will go in this way. 3s are 9, again 1 0, it will move on in this way. So this is equal to 0.333. We don't know where it is ending, but we can understand one thing, that the same number is getting repeated after the decimal point. So such type of numbers are following a particular pattern of repetition. This we can write it as actually 0.3 bar, or we can write this as 0.3, a dot above the number 3. This dot or this dash usually signifies that the number 3 is getting repeated more than 1 or 2 times. It's repeating infinite times. This decimal representation will actually never end. Coming to the last type, that is non-repeating, non-terminating decimal numbers. So these are such type of numbers which do not follow any particular pattern. As you can see over here, it's following a particular pattern, that is 0.3333. But over here, it will never follow a particular pattern. Like for example, if I'm taking the example like 22 by 7. Suppose we are dividing 22 by 7. So 22, 7, 3s are 21, 1 0, point, 1s are 7, that is 3, again 4, 28, again 20. In this way, as you can see, it's getting repeated up to, we don't know what is the exact pattern of repetition. It's moving on in this way. That is, if I write this, it will come 3.14 dot dot dot. We don't know up to which number it's getting repeated. So such type of numbers will be called non-repeating decimal numbers. Non-repeating, non-terminating decimal numbers. So we have learned actually 2 types. Terminating, where the number terminates, where the decimal actually terminates after few places of after the decimal point. In repeating non-terminating decimals, there is an exact pattern of repetition of the numbers, and in non-repeating, non-terminating decimals, there is no pattern of repetition of the numbers, as you can see over here. Now we will represent rational numbers and irrational numbers on the basis of this terminating, non-terminating decimals. I'm clearing the upper part. Now you have to understand this, and you have to also remember that rational numbers, this terminating is actually rationals. Repeating is also rational, and non-repeating is irrational. Let's come to the conclusion that decimal expansion of rational numbers can be either terminating or repeating decimals. Rational numbers can be either terminating or repeating. That means such type of numbers will be having criteria of this two. First is terminating and the second one is repeating. Like for example, if I'm taking the number 1 by 4 and you already know now that what is a rational number. As you can see over here, 1 and 4 both are integers where the denominator is not equals to 0. So such type of numbers obviously is a rational number, and 1 by 4 we have found we have done the decimal representation, it's coming 0.25. So here it's terminating after a certain point, certain time interval. After two places, it's terminating. Also, if you take the example 1 by 3, that is 0.3 bar. It's a repeating non-terminating decimal, which is also a rational number because 1 is a integer, 3 is also an integer. So both are integers, as well as the denominator is not equals to 0. Also, both the numbers are in simplest form. Here, therefore, we can say that they are rational numbers. So we have come to the conclusion that decimal representation of rational number is actually terminating or repeating decimals. Now we can easily change a number which is in the form of fraction to repeating or non-repeating decimals. But from repeating decimals to fraction, we don't know the trick actually. I'll show you the trick, then I'll show you the process how to calculate. For example, if I'm taking one example as 6.534 bar and the bar is above 3,4, it's not above 5. Let me take another example to give you one fact. 5.1 is equals to 5 plus 0.1. This you can write it as 5 plus 1 by 10, which is equals to 5.1. And this also we can write it as 5 whole 1 by 10, that is 51 by 10, that is 5.1. Similarly, over here also, what is the number before the decimal point? It's 6. So this number should also be of the form 6 whole some fraction. So how to write that fractional form? It will not be that easy as we are writing in this case, because in this case there is bar in this fraction, in this repeating decimal. So here we come to the trick, and that is 6 whole. How to calculate? So we'll put a dash over here where we will write the fraction. Kindly listen to the trick. What is the number which is not repeating after decimal point? That is 5. And which is the number which is repeating after decimal point? That is 3 and 4. So that we first and foremost, we will write the entire number 534, which is the number, minus of what is the number which is not repeating? That is 5. This should be in the numerator. And what will be in the denominator? Denominator you have to write first how many numbers are getting repeated? 2 numbers are getting repeated. So you have to replace the number which is 3 and 4 by 9. And how many numbers are not getting repeated after decimal point? Only one, and that is 5. So we will replace the number 5 by 0. So this will be equals to 6 whole 529 divided by 990. If you calculate this with the help of a calculator, you will find that you are getting 6.53434343434, because we know 6.534 bar is equals to 6.5343434 ... Now let's come to some other examples. I have to erase this part. Let's come to some other examples. 467 and the bar is on 67. So how to write in this form? Now easily you can use the trick to write. It will be 3 whole 467 minus of what is the number which is not getting repeated? 4 divided by how many numbers are getting repeated? 2 numbers. Replace the 2 numbers by 9. How many numbers are not getting repeated after the decimal point? That is 4. So it will be 990. So this will be equals to 3 whole 463 by 990. Coming to another example. If it is 2.34 bar, this is equals to 2 whole. This will be 34 minus 3 as because 3 is not getting repeated divided by 90. That is equals to 2 whole 31 by 90. Now this is the trick, but during your school examinations, you cannot use the trick to find out. There is a certain method to calculate. Now I'll come to that method, that how will you calculate. Questions will come in this way, that represent 6.534 bar. Bar is above 34 into fractional form. Now the question is represent 6.534 bar into fractional form. Now we know that we can write 6.534 bar as equals to 6 plus 0.534 and above 34 there is a bar. Now let us take that this part x, this part is equals to x. Now if you multiply with 1000, how much will you get? Why am I multiplying with 1000? Because after decimal point there are 3 numbers. We are not considering the repeating numbers. We are considering them as 2 numbers only because bar is above 2 numbers. So 1, 2 and 3. So we are representing this as multiplying this x with 1000. Now if you are multiplying this with 1000, how much will you get? Look over here. This number I can write it as 5343434 ... Now this is equal to 0.534 and from here to the last we can write this as 34 bar. Now if you multiply the whole number with 1000, how much will you get? Suppose if I am multiplying this number with 1000, how much will you get? After decimal point, how many numbers are there? 1, 2, 3, 4, 5. So it will be 53434 bar by 1, 2, 3, 4, 5 into 1000. 3 cancel, 3 zeros are cancelled. So this will be 534.34 bar. Again, we are multiplying x with 10. Actually, we have to get rid of the recurring. So somehow we have to get rid of this recurring number. So if you are multiplying the number with 10, how much will you get? Again, this number, if I am multiplying with 10, how much I will get? 0.534 bar multiply 10. This will be equals to 534 bar divided by 1 upon 1000 into 10. 10 cancelled. It will be 534 bar. So here it will be 5.34 bar. Now this is one equation, this is one equation. If you try to subtract these two equations, 1000x minus 10x will be equals to 990x. And this will be, if you subtract these two numbers, 34 bar will become 0. And this will be 534 minus 5, that is equals to 529. So if you are calculating x, this will be 529 by 990. So therefore 6.534 bar, this will be equal to 6 plus 529 divided by 990, which you can write it as this part, which you can write it as 6 whole 529 by 990. Just now I have shown you in this short form that this number is actually 6 whole 529 by 990, which are actually tallying. So this is the method which should be followed in your school to answer the questions, but this is a trick where you can do this in rough and you can check your answer is correct or wrong. So here I end my part 3 of number system. I'll be uploading soon part 4. Please continue to share your love and blessings and feel free to drop your queries in the comment section.